Um, yeah, so I'm Caleb Stanford from University of Pennsylvania. Thanks a lot for being patient to join us in getting into lunch a little bit. This is joint work with Konstantinos, Kallas, and Rajeev Alur, also at Penn, and I'm also in the job market this year in programming languages and data processing kind of intersection. So stream processing is increasingly relevant today. We know there are increasing number of applications, companies such as Databricks, Materialize, and AWS. We heard a little bit about Databricks yesterday, and platforms such as Spark, Flink, and Storm that are popularly in use for stream processing workloads. Despite all of this interest and relevance, these systems are actually a real struggle for many users to use, especially for more complex applications. And there's not a lot of work looking at formal correctness or correctness tool support for these systems. So for example, in this work, Big Debug, they comment as follows: the nature of debugging is post-mortem. Developers are notified of runtime failures or incorrect outputs after many hours of wasted computing cycles on the cloud. So users are really struggling with how to ensure that their applications are correct. And typically they can only find the complex bugs after they've already deployed some application over a ton of data, and it's a real pain to figure out exactly what went wrong. So we'd love to provide formal correctness support for stream processing systems. Unfortunately, before we can do that, there's kind of a major obstacle we need to surmount, and that is there's no unified language standard in this space today. So like different systems make completely different choices about semantics and disagree on them. For example, are graph edges in a data flow graph ordered or unordered? For example, are streams partitioned in an explicit way by the user, or is the partitioning inferred? And then as well as trying to support complex features that different systems have, such as stateful operators, external services, and iterative computation and cycles. So different systems make different choices here, and there's no standard that says, here's what a stream processing program is, and here's what it means to be correct. And this is in contrast to relational algebra world, where of course we know that relational databases are built upon at least in the core, kind of a very well understood semantics. And they have benefited vastly from that in the ability to build verification and correctness tools. So that's the challenge. But the opportunity here is that there are some kind of dimensions of correctness that we've identified and that others have identified that are kind of common to all systems. And I'll just mention four, and you can read more about it in the paper. So order-aware computation is a huge aspect of today's stream processing systems, where you kind of want to know which operators are aware of the order of the input and which are kind of independent of that input of the order. Correctly distributing complex stateful applications, providing performance guarantees. So the correctness of stream processing systems critically depends on the performance of the operators. If they're straggling or they crash, then the whole thing is just going to crash or not be correct. And finally, fault tolerance, which has seen a lot of work, but there's been less attention to the other three aspects here. And this is really an open call for people to work on this in this space. I'd love to talk about what you think are the kind of barriers to correctness in stream processing, and what, if you have any other ideas for what formal work in this space should tackle. So our vision for this space is that you might have kind of a unified framework for stream processing that you also have formal analyses built in. And so here on the right of the slide, you can see, for example, you have pluggable formal components that do things like tracking distributed assumptions, tracking ordering requirements, and tracking performance guarantees on the system. Thank you.